Good evening, students. Welcome to the Arihant Academy YouTube channel. We are here to take a revision lecture on chemistry. I'm Poonam Malik. I represent the chemistry department of Arihant Academy. And we are doing the chapter chemical bonding, which is an ICSE chapter, the second chapter to be precise of your syllabus. And let us just talk about the weightage of the chapter first. See, in earlier board exams, this chapter carried a weightage of about 4 marks, 5 marks approximately. There is no fixed weightage of any particular chapter. It fluctuates every year. But on an average, we have seen that there are about 4 to 5 marks of questions asked every year from this chapter. But with the current pandemic situation, syllabus being reduced in other chapters, it's quite likely that the number of marks in this chapter may be higher. So what you have to do is prepare the chapter well, because this is a chapter where nothing is omitted. Everything that is there in the syllabus is included, and we have to prepare accordingly. So let's proceed with the chapter chemical bonding. The first thing that we have to understand regarding a chemical bond is it is a force which holds two or more atoms together in a stable molecule. All of you please understand that the areas marked red on the screen are important, and they are your definitions. So a chemical bond is the force which holds two or more atoms together in a stable molecule. This is exactly what you write if a question is asked, a definition is asked on chemical bond. And as you know, like the human body has the smallest unit as a cell. इसी तरह से an atom is the smallest unit of matter which takes part in a chemical reaction. And in lower classes, we've also studied that an atom is made up of protons, electrons, neutrons, right? Protons and neutrons are in the center, in the nucleus, and electrons are outside in the orbits. There are three names for orbits. We call them shells, we call them energy levels, and what else? Orbits. So three names, all three meaning the same. Now the question arises, why in chemistry why do elements react? The first thing you need to understand is there is something known as the octet rule and the duplet rule. Inert gases or noble gases follow the octet rule. There are 8 valence electrons, and the last valence shell cannot hold more than 8 electrons. So if it has achieved the 8 electrons level, it is stable, and all the others which have not achieved 8 electrons in the last shell would be unstable. So let us compare an atom of sodium with an atom of neon. Sodium is a metal. It has electronic configuration 281. Neon is 28. Now what happens when you look at this? Sodium would want to become like neon. Everyone likes stability. Similarly, the elements also want to be stable. So sodium will give up 1 electron and take on the electronic configuration of neon. So kya ho raha hai? When we have these noble gases, all the elements want to imitate the configuration of the noble gas. So they will give electrons, they will take electrons, they may share electrons to become stable. Out of 118 elements in chemistry, 6 are non-reactive. We have 6 noble gases. What about the remaining 112? 112 are reactive. So that gives us an immense idea of the number of bonds and the number of compounds that can be formed. So we move on to the next slide. The atomic number of any element is the characteristic of that element. Like as I have earlier also mentioned many times, like when you have a cricket player, if he's wearing a jersey of number 10, you know probably it's Sachin Tendulkar, right? So इसी तरह से atomic number is unique to the element. No other element is going to have that atomic number. If I talk about types of elements, we can classify elements into 4 categories in chemistry. We have metals, we have non-metals, we have metalloids, and we have noble gases. 1, 2, 3 in the outermost shell would be a metal because it's easier to donate. And 4, 5, 6, 7, 4 would be a metalloid mostly, but it sometimes also falls under the non-metal category. 5, 6, 7 in the valence shell, of course, they would gain electrons and become negatively charged ions. So metals give up electrons and become electropositive. Non-metals accept electrons and atom neutral है तो accept किया तो obviously electronegative हो जाएगा. Now, how does something combine chemically? 1, there can be a transfer of valence electrons, and 2, it can be sharing. So when there's a transfer of valence electrons, the kind of bond will be an ionic bond or an electrovalent bond. When there is sharing involved, it is a covalent bond. From here, we move on to, there are 2 rules of stability which the inert gases follow. The duplet rule, that is, if there's only one shell only, that is the K shell, then the rule is the duplet rule, that is 2 electrons in the first shell. But if there's anything more than 1, suppose it's 2, 3 more, तो last shell में, last वाले में 8 होना चाहिए, and that is the octet rule. And remember, the last orbit can never have more than 8 electrons. So that is one thing you have to keep in your mind. And from here, we move on to how do we get the ionization potential. Suppose it's a metal. अगर उसका IP low है, IP is ionization potential, which we've studied in periodic table. Then the cation, metal will easily lose electron and it will be easily formed. The cation will be easily formed. Electron affinity is like if we have a higher electron affinity, that means it's a non-metal. And if that is higher, then the ease of formation of an anion is greater. And electronegativity, जितना ज़्यादा difference, उतना अच्छा ionic bond बनेगा, ionic compound बनेगा. Covalent compounds, basically let's go back to ionic compounds. Ionic compounds are formed between metals and non-metals. यानी electron donor और electron acceptor. जब इस तरह का bond बनता है तो it's an ionic compound. When we talk about covalent compound is when there is no electron donor, yani there is no metal involved. No metal involved means it is a non-metal combination, and obviously they will, since they are both non-metals, they will have high electron affinity, high electronegativity, and the electronegativity difference should be minimum, it should be negligible between the 2 combining atoms. Only then there will be sharing. If the electronegativity difference is large, it will be an ionic compound. So when we understand that a metal loses electrons, for example, we took the example of 281. It wants to achieve the configuration of the nearest noble gas. So it will give up the last one. See, it has 2 options. Either it can give up 1 or it can take 7. So obviously it will do less work. So it will give up 1. Atom is neutral, उसके पास positive, negative दोनों equal हैं, और दोनों equal हैं, इसलिए वो neutral है. लेकिन the moment it gives away 1 electron is less and 1 proton has lost its partner. So metals become positively charged because 1 negative charge is less. If the metal loses 2 electrons, it will be having 2 positive charge. If it loses 3 electrons, it will have 3 positive charge. And that is the valency. And they become stable. The configuration for X in this case becomes 2,8. But it has become charged. Similarly, 287, Y atom will accept 1 electron. जब वो accept करता है तो क्या होगा? वो भी स्टेबल हो जाएगा, 288 हो जाएगा. नियरेस्ट इनर्ट गैस कॉन्फ़िगरेशन बनेगा कौन सा वाला, हीलियम नियॉन आर्गॉन. इट विल बिकम लाइक आर्गॉन. And now they're both oppositely charged. One is a plus, one is a minus. There will be an attraction between them. And since these are opposite charges, there will be a bond formation which will be pretty strong, and that is due to the keyword here. Keyword, remember in all your answers, when you mention something like that, electrostatic force of attraction between two oppositely charged ions. So if you are missing out on certain important words, you'll say there is attraction between cation and anion. Fine. But when you present a good answer, you have to mention electrostatic force of attraction between two oppositely charged ions. So this is an important word which an examiner is basically looking for, right? So finally, by the cross drop technique, when we combine X and Y, we are getting a compound XY. You've done your cross drop technique in language of chemistry in 9th standard. So we move ahead from here. Let us understand what exactly do we mean by an electrovalent or an ionic bond. It is a bond which is formed due to transfer of one or more electrons from a metallic element which is electropositive to a non-metallic element which is electronegative. तो जब ये बॉन्ड बन रहा है, जब ये आयनिक बॉन्ड बन रहा है, तो कंपाउंड फॉर्म्ड बाय दिस मेथड would be an electrovalent or ionic compound. So basically, electrovalent, ionic both mean the same thing. And we also understand that an atom will become an ion if it loses or gains electrons. So electrovalency is, of course, we can talk about the valency of the number of electrons accepted or donated. Now here we are playing a very important slide, which is the oxidation reduction part. And here, even electrolysis chapter mein, yeah, in many other places, you are going to talk about oxidation and reduction. I'll give you a simple formula to remember this. LEO, I repeat, LEO, Leo, and GER, GER. लियो गर करता है, छोटा सा लाइन गर कर रहा है. लियो इज लॉस ऑफ इलेक्ट्रॉन ऑक्सीडेशन and gain of electron reduction. So if you're ever confused whether this thing is undergoing oxidation or reduction, you have to repeat Leo Gar. Loss of electron, oxidation, gain of electron reduction. But I repeat that you have to keep this loss or gain to the left of the equation. Like there are many times where we may write something to the right side of the arrow, but you can transfer it mathematically to the left. Like we have Na minus 1 electron becomes Na plus 1 plus, Zn minus 2 electrons, Zn 2 plus. I can alternatively write it as Zn arrow Zn 2 plus plus 2 electrons. So I can just shift the 2 electrons to the left and mathematically it becomes a minus, and then I can apply my Lioger. The mnemonic that I give you is for the left side of the equation. Similarly, if something gains electrons, that is gain of electron reduction. तो यहाँ पे जो already positive है, negative लेके neutral हो जाएगा. जो already 3 plus है, if it accepts 1 electron, it will become 2 plus. And if it is Fe3 plus and accepts 3 electrons, it will become a neutral atom. Because 3 plus is cancelled by 3 minus. So we have to remember the oxidation and reduction because we are going to use it a little further. Let's go to the formation of ionic compounds, the first one being sodium chloride. Children, you have to practice your electron dot diagrams. If you're not doing that, don't think it's going to be magic and you're going to get a perfect diagram just by reading the text. No. This is one place where you all ignore the matter and then end up making huge mistakes in presenting it. So, and the way I've noticed it Quite a lot of you lose entire marks in the electron dot diagrams. So let's go to how do we approach the formation of sodium chloride. We have sodium, which is atomic number 11, characteristic of the element sodium, and the atomic number is 281. And obviously, it would give up 1 to become 28 to become stable. Chlorine, 287, would become 288. And obviously, Na becomes Na plus because it has lost 1 electron. Cl becomes Cl minus, it has gained 1 electron. And you can see that on the ionic equation. Na minus 1 electron becomes Na plus. To the left, let's go to Liogar, loss of electron oxidation. So we have oxidation written there because Na atom has lost an electron. Cl has gained an electron to become stable, and therefore it is a reduction process. Egg side oxidation, egg side reduction, and they have become charged. And since opposite charges attract, Na and Cl will come together and give you a compound with a sodium chloride, and it's a strong compound. On the other side, children, remember, even if the configuration of sodium is 281, we are only going to take the last shell into account, which has just 1 electron. Do not try to draw the other shells, the other electrons, just the last one, which is the valence shell. Okay, just that one. In 287, we have to concentrate only on the 7. Now, Na is going to, it's the metal, it's going to give 1 to Cl, it will accept that electron, and क्या बन रहा है? Sodium 1 plus बन गया, electropositive, Cl 1 minus बन गया, and we put them in the box brackets, and they have become ions, sodium cation, chloride anion, and together they form the sodium chloride molecule. Practice this well, and this is a sure, one or two of these are sure short questions in the exams. So practice this well. Let's go to the second diagram, calcium, which is 22882 would give up the last 2. Oxygen, 26 will accept 2. So obviously Ca becomes 2 plus, oxygen becomes 2 minus. And by the cross-drop technique, the 2 plus and 2 minus will cancel and we get CaO. So we have this, Ca minus 2 electrons, Ca2 plus, O plus 2 electrons, O2 minus. And we have the 2 plus and 2 minus attracting each other and forming CaO. Once again, the electron dot structure, 2 electrons, 288, calcium giving up 2, oxygen in the outermost shell we can see 6. So calcium is going to give 2 there and complete the 8 of oxygen, and calcium will lose its outermost shell, that is those 2 electrons. Calcium becomes 2 plus, oxygen becomes 2 minus, and we get calcium oxide. Similarly, when we go to magnesium chloride, Mg is atomic number 12, that's 282. लास्ट के 2 electrons हटेंगे और 28 बन जाएगा, और because 2 electron हटे, we are getting 2 plus there. Since the valency of magnesium is 2 plus and Cl is 1 minus, by the cross-drop technique, you will realize that in this case, we have 3 atoms participating because the formula is MgCl2. So there are 3 atoms, and how do we represent the 3 atoms? 1 Mg and Cl2, and Mg gives 1 electron to both, 1 to this Cl, 1 to that Cl, and we are getting Mg2 plus and 2 chloride 1 minus ions with a formula MgCl2. So you remember your valency, you remember your cross drop, and that is going to guide you as to how many atoms are going to get involved in the reaction, in the formation. From here, I think we have just 3 examples in the portion, and one is sodium chloride, the other is calcium oxide, and the third one is magnesium chloride from ionic bonds, ionic compounds. So you perfect these 3 areas, And I guess you're done with the ionic compounds. That's not too much work. Please follow your ionic equations and the electron dot structures. Practice them about 4 to 5 times, and I'm sure you'll be perfect. Let's go to covalent compounds. Now, this is, as I told you, this is a combination between a chemical bond formed due to mutual sharing of electrons between the given pairs of atoms of non-metallic elements. So we don't have a metal for covalent bond. There is no electron donor. तो अगर आपके पास कोई भी atomic number है which is like 281 or maybe 283, obviously it will not form a covalent bond. A covalent bond will be like maybe sulfur dioxide, where sulfur is a non-metal and oxygen is again a non-metal. So non-metal, both are electron acceptors. They don't have a donor, so they don't have a choice. They have to share electrons आपस में. Both are electron deficient. Both are falling less in electrons to complete the octet. They will share electrons. Now, if the pair of atoms, we can have 2 atoms, we can have more, but if the number of electrons shared is one pair, then a single covalent bond is formed. One pair, single covalent bond. Two pairs, which is 4 electrons, would be a double covalent bond, and 3 pairs, which is 6 electrons, would be a triple covalent bond. So remember, you have to count the electrons that are shared to decide कि कितने bonds बने. We go to covalent compound. Again, the compound formed due to a sharing of electrons between the given pairs of atoms is called as a covalent compound. Anything highlighted in red is your definition. See that you learn and perfect that. Because in definitions, laws, and terms, these are 3 things I repeat. Definitions, laws, and terms, you're not allowed to change a single word. It has to be exact. In chemistry, we don't encourage you mugging up equations and other things, but these 3 things have to be perfect. So see that you learn it perfectly. Let's go to understanding non-polar covalent compounds and polar covalent compounds. Now, this is a slightly tricky area. Covalent compounds are said to be non-polar when there is equal distribution on all sides. If there are 2 atoms, equal distribution of electrons between 2 atoms. Sometimes I have seen maybe 5 atoms involved, and yet there is equal distribution on all sides. But if there is some inequality, then it can result in the formation of polar covalent compounds. Like, for example, when we talk in terms of water, water is H2O, सबको पता है H2O water है, लेकिन water में hydrogen एक non-metal है. Yeah, I know a lot of y'all are going to say hydrogen as atomic number 1. We place it with metals, but it's a non-metal. If you read up about hydrogen, it is basically a non-metal. Oxygen is also a non-metal, and therefore the bond formed is going to be covalent in water. But the problem here is that oxygen is pretty electronegative. Oxygen is very electronegative. वो खुद का इलेक्ट्रॉन अपने पास रखता है, हाइड्रोजन का इलेक्ट्रॉन भी अपने तरफ पुल करता है. So basically, the electronegative nature of oxygen, hydrogen has just 1 electron, and that is being pulled by oxygen in one side. So hydrogen gets a slight plus charge because it's left with just 1 proton. See, let us reflect to what a hydrogen atom is. It has 1 proton, 1 electron. That's it. So if the electron is pulled away, it's left only with the proton, which is the positive charge. ठीक है, और ऑक्सीजन की तरफ नेगेटिव चार्ज हो गया, तो यहाँ पे पोलैरिटी आ गई because of the nature of oxygen. So there is a kind of charge separation, which actually covalent compounds में कभी भी हम charge नहीं बनाते हैं. We never make charges. It is ionic compounds where we show plus minus, but not in covalent compounds. So the atom which attracts electrons more strongly obviously develops a slightly negative charge. In the case of water, it is oxygen, and hydrogen would develop a slight positive charge. So depending on the nature, the electronegative nature of which two atoms or three atoms or maybe more have combined. The nature of electronegativity plays a role in causing polarity. Let's go to formation of hydrogen. Hydrogen has just one electron in the outermost shell, so obviously hydrogen plus hydrogen, the second electron. I'll tell you a method of calculating this. Just, it's going to guide you when you do your diagrams. Hydrogen is atomic number 1, wants to become 2. That is the duplet state. First shell hai, ek hi shell hai, so obviously it wants to go to the duplet state. So, how many less? Calculate how many less. It has just 1. And how many less for 2? 1 less. So, hydrogen will contribute 1 from each side. And therefore, one pair of electrons will be shared in the center. You can see those two dots. Those two dots are representing electron of hydrogen, and you get a single covalent bond because I said one pair of electrons and one single covalent bond, and we get the formation of hydrogen molecule H2. Very simple electron dot structure, very easy to make. But remember, one electron pair shared. Next, chlorine. आउटरमोस्ट शेल लेना है, पहले वाले शेल्स नहीं ले रहे, 2 8 नहीं लेना है, सिर्फ 7 इलेक्ट्रॉन्स लेने हैं. And obviously, how many less to become an octet? In 7, we have 1 less. So we calculate 7 minus 1. So 6 will be left with the atom of chlorine and 1 will go for bonding. Once again, I repeat, 7 electrons in the outermost shell. Octet होने के लिए एक less है. So it will contribute 1 towards sharing on both sides, from this atom as well as that atom. And in the center, we'll get 2 electrons shared and 6 electrons left with each chlorine atom. 7 minus 1, 6, and 1 from each side shared. Now when you count the common electrons with the others. So each atom of chlorine is now having 8 electrons. You can count the dots. You can count the electrons. So though common electrons go, you have to count on the left side as well as on the right side. And both chlorine are now having 8 electrons. So both are satisfied. And therefore, we're getting a single covalent bond. That is, one pair of electrons shared, chlorine molecule is formed. Single covalent bond. Oxygen, atomic number 8. Configuration 2 6. How many less to complete octet? 2 less. 2 electrons less. We take the outermost shell, draw the 6 electrons for oxygen atom. Since 2 are less, 2 will go for bonding from each side. How many are going to be left outside? So we have 4 electrons in the center. 4 electrons in the center means it's going to be a double covalent bond. Look, kids, there's a difference between saying single covalent bond, double covalent bond. I can say 3 single covalent bonds in certain places. I can say a triple covalent bond in one place. So when you have 4 electrons shared in the same place, only then we say it's a double covalent bond. Because I can show you some more examples where you will get 2 covalent bonds, but they're 2 single covalent bonds. 2 single और double में एक difference है. 4 electron in one place, double. 2 on one side and 2 on the other. Again, we have 2 bonds, but they are 2 single covalent bonds. I'll show you an example of that also. Let's first do the example of nitrogen. Nitrogen, which is atomic number 7. So we split it as 2 5. Again, tell me how many less? 3 less. So 3 less, 5 minus 3. So 2 electrons will not get involved in bonding. So 3 from each side will be put in, and 3 and 3, that is 6 electrons will be shared, and therefore 6 shared matlab kitna covalent bond? 3, triple covalent bond. A single, एक ही triple covalent bond बन रहा है nitrogen molecule का. तो यहाँ से हम आगे चलते हैं. We go to a slightly complicated diagram, which is CCl4. Carbon tetrachloride, carbon atomic number 6, which is 24, chlorine 17, which is 287. I'm only concerned with the 4 and the 7 for the covalent bond. I'm not going to look at the earlier shells. Okay? So now look at this. Carbon had just 4 electrons, so I represent it with X. Carbon electrons are shown as X. Since they are two separate elements, see, the earlier ones we took all dots. We took for hydrogen, we took dot. For oxygen, we took dot. For electron representation, for nitrogen, we took a dot because both the atoms were the same. Nitrogen, nitrogen, oxygen, oxygen. But here now I have a different element. I have carbon and I have chlorine. So since they are two different elements, I will represent the electron of one by X and the other by dot, so that there is a clarity on which electron belongs to which atom. So carbon I have surrounded by 4x and 4 chlorines are coming in from the sides. Children, let's go to the cross-drop method. C carbon balance C4 and chlorine 1 minus. So my compound is CCl4. CCl4 matlab 5 atoms, 5 atoms participating. So 4 chlorines coming in from the sides. Okay, and of course I'm showing a plus sign there. I'm showing a plus sign in between. So we have the 4 chlorines coming in, and therefore an X and a dot are coming together, and that represents one single covalent bond. And how many X and dots can we see? We can see 4. Carbon surrounded by 4 X dot. 1 electron of carbon. X is the electron of carbon. Dot is the electron of chlorine. And obviously on all the 4 sides, we are getting 4 single covalent bonds. Actually, there are 8 electrons which are shared, but in different directions. So we call it 4 single covalent bonds, CCl4. Something similar, that is for the covalent compound of methane. CH4, carbon has 4 electrons in the outermost shell. H has 1 electron which is going to come in from 4 sides, and again there's a plus sign in between, and this is before combination. After combination, the X and the dot form 4 single covalent bonds again. And over here, do you have polarity? Let us discuss that. Is there a polarity? No, because there is equal distribution in all directions. So this cannot be a polar molecule. Polar covalent molecule नहीं है, ये non-polar है. Non-polar covalent molecule. Even CCl4, there was equal distribution on all sides. So now let's go to something which is polar. We're just studying the structure of water. Water H has 1 electron in the outermost shell. Oxygen has 6. Cross-drop technique, H1 plus, oxygen 2 minus. क्या बन रहा है? H2O. यानी कितने atoms हैं? 3. H2O, H के 2, oxygen का 1. दोनों H side से आएंगे. 1 electron each contribute करेंगे to the sharing. Oxygen will also contribute 2 electrons from the center. And we have the X and dot. That is, the X is the electron of hydrogen, dot is the electron of oxygen. So we have 2 X dots at the side, and we get 2 single covalent bonds. Children, remember, they are in 2 different directions. And therefore, there are 2 single covalent bonds. I'm not going to call it a double covalent bond. I know of a certain school which has, which has asked students, like, what is the kind of bond formation in this particular compound? And the children ended up writing covalent bond. And they gave quite a lot of kids 0. Reason, because they wanted answers like 2 single covalent bonds, a triple bond, a triple covalent bond, a double covalent bond. So they were very specific with the type of answers they wanted, and that is something you have to follow in the boards also. So please be specific. When you write covalent bonds also, please mention 2 single covalent bonds for water at least. यहाँ से जाते हैं हम again एक और compound पे, nitrogen and hydrogen, that is atomic number 7, which is 2,5. How many less? We go to the calculation. How many less? 3 less. So obviously NH3 is our formula for ammonia. NH3 and hydrogen 1 है ना. तो ये हमारा स्ट्रक्चर आ रहा है NH3 का, क्योंकि हमने कहा कि 3 इन्वॉल्व होंगे बॉन्डिंग में, तो 3 towards 3 sides have taken X of nitrogen, and out of 5, 3 got involved in bonding and 2 are left out. Now, here I have the definition of lone pair of electrons. What do we mean by lone pair? In the valence shell, which means the outermost shell of an atom, when we have 2 electrons which are not participating in bonding, we call them as lone pair. I repeat, in the valence shell of an atom, when a pair of electrons is not participating in the bonding, we call it as a lone pair of electrons. Nitrogen, you can see there is 1 lone pair. दो X एक side में हैं and they are not participating in the bonding. So we have X and a dot coming in from hydrogen, NH3, and we have 1 lone pair. Obviously 3 जगह bonds बन रहे हैं. Even if you go by the cross-stroke method, nitride N 3 minus है valency, H1 plus, आपका टेक्निक से आपको फॉर्मूला मिलेगा NH3. तो आपको मालूम है how many atoms are involved? It is 4 atoms. So we have 3 single covalent bonds as is represented here. We've understood what the structure of covalent compounds. And also I would like to explain to you what is happening due to the lone pair. Now water, what we drew was a symmetrical structure, okay? 1 H on this side and 1 H on that side. But actually water gives you this kind of arrangement, a V kind of structure. दो H और एक V structure बन जाता है. दोनों lone pairs of oxygen, you can see in water we have 2 lone pairs. Go back to the structure of oxygen. In oxygen we have 6 electrons in the outermost shell, out of which 2 are shared with hydrogen, so there are 4 left, and therefore there are 2 lone pairs of electrons. Now both the lone pairs go towards one side, and we have this V kind of structure for water molecule. So water molecule is not exactly a very straight kind of structure. It is a angular structure. It has 2 lone pairs. Ammonia has 1 lone pair. And how is this lone pair going to affect us? The lone pair effect. Kids, when we talk about lone pair effect, all your reactions of dilute acids in the chapter HCl, H2SO4, HNO3, all the dilute acid reactions are due to the formation of something which is known as hydronium, which is H3O+. Now, let's understand a concept very clearly, because this is a frequently repeated question in the boards, and majority kids end up getting a 0 because they make mistakes in drawing the diagram. In, like, for example, here where we have the hydronium ion, there is this brace bracket with a plus written outside it. A lot of y'all don't draw that brace bracket, y'all don't draw the plus, and your electrons are all messed up. It's not clear, and one mistake gives you a 0. So this is something which is asked for approximately 2 marks in the boards, and it's very easy to grab those 2 marks if you practice the diagram. This is a diagram based chapter. You have to sit and practice. You have to sit and draw each electron dot diagram at least when you are drawing it about 3 to 5 times, you'll get perfect with it. So hydronium ion water molecule to humko samajh gaya tha, so we know that V kind of structure of water molecule, which is shown first over here. Now what happens in the case of acids में H plus part of the formula होता ही है, H तो होता ही है acid में. HCl, H2SO4, HNO3, all the acids have H. Now what is happening that H has just one electron, but some electronegative member has pulled. And so H has become only proton. Once again, I'm sorry. Once again, we have H plus in the sense, let us imagine the atom of hydrogen, one proton, one electron. Electron किसी ने अपने तरफ खींच लिया है, which is probably like oxygen or chlorine, which are electronegative elements. And so H is left with just the proton. Now a proton obviously would be unstable, positive charge है. उसको stable होने के लिए, for even if it's just the first shell, it needs minimum 2 electrons. So it goes looking for, electrons, and it comes across this water molecule where there are 2 lone pairs. So wonderful, it has found what it wanted. It's getting 2 electrons from, water. So we have the attachment of H plus to water, and the plus sign of H plus is transferred to the entire H3O plus. So we put a brace bracket there with a plus. Now listen children, there are 2 things we must pay attention to. For the formation of hydronium ion, or even we talk about ammonium ion, in both cases, there has to be lone pair available. And there has to be a requirement for a pair of electrons. It's a matter of demand and supply. H plus has lost its electrons and it's only left with 1 proton. To become stable in the first shell, it needs the duplet condition. 2 electrons in the first shell. So ये क्या करेगा? It is going to approach water, and water is going to give both the electrons. Normally, this is not a covalent bond. In a covalent bond, there is sharing from both sides. Here, there is no sharing from both sides. Water is supplying both the electrons, oxygen atoms say, to hydrogen. So, as you can see, you can represent it in 2 manners. Either you can write 2 dots for the electrons of oxygen and then an H and a brace bracket with a plus, or you can show an arrow, which is the symbol for coordinate covalent bond. The arrow here represents the coordinate covalent bond, which is telling you which atom has given 2 electrons to which atom. So that arrow is indicating that oxygen has supplied 2 electrons to hydrogen. And in this manner, we have the formation of the hydronium ion H3O plus. You have always studied about H2O, water, but you never knew that there was something called as H3O plus which exists, and this causes a lot of chemical reaction in chemistry. So very important 2-mark question, just 1 equation you have to write, and if you do that perfectly, you get your marks. Also an area where paper checkers are looking for mistakes, and they find 1 mistake and you lose your marks. To be very honest, kids, chemistry is not a subject where the marking is easy. Either you get full marks or you get 0 marks. There is no half correct equation. Everything has to be perfect, then you get full marks. So practice all the diagrams, all the equations that are shown here. Similarly, now we're going to the formation of ammonium ion. Ammonia, as we drew it, showed us ammonia molecule is having 1 lone pair, and you can see that at the side, formation of ammonium. जब हम ammonia gas बोलते हैं, it means NH3. When we say ammonium, It is NH4 plus. So when it reacts with something like ammonium chloride, ammonium sulfate, we are using NH4 plus. We are not talking about NH3. There's a difference between ammonia and ammonium. Ammonia is NH3. Ammonium is NH4 plus. So don't use the word loosely. Ammonium is when it combines. It combines with something, tab ammonium bolenge. Otherwise, we will call it ammonia. Ammonia is a gas, NH3. Now, once again, a similar situation comes up. NH3 has a lone pair of electron, and H plus has lost its electron, and it's left with just a proton. And it's again looking for, again, we come up with a demand and supply situation. H plus attaches itself. There is a lone pair available condition 1, and there is some element, some ion, which requires stability. So they both come together, and once again, we get a coordinate covalent bond there. Not to forget the H plus ka plus, which is transferred to the brace bracket. Upar, brace bracket ke upar, please write the plus. So this gives you the formation of ammonium ion, and you can see the arrow. The arrow tells us nitrogen is giving both the electrons to H. It is not mutual sharing as we studied in covalent bonds. So till now, we have studied 3 kinds of bonds. 3 kinds of bonds which are ionic bond, where it was a transfer, it was between a metal and a non-metal, electron donor and electron acceptor. The second kind was when there was mutual sharing of electrons. And that is between non-metal. And the third type, which we studied now, is the coordinate covalent bond, where one atom is giving both electrons to the other. So this is an important area from the lone pair effect and hydronium ion, ammonium ion. Frequently asked board questions. Also, another thing which I would like to point out is sometimes, like if I rightly remember, there's a 2007 ka question which says when a nitrogen molecule is formed, how many electrons are left with the nitrogen atom on each side? Meaning they're not talking about sharing. Children, let's calculate. Nitrogen atomic number was 7. So it translates as electronic configuration 2, 5. How many less to become 8? 3 less. So 5 minus 3 makes it 2. So each nitrogen atom would have 2 electrons which are not participating in bonding. So this was a 1-mark question in 2007. Old question, but yes, certain objective kind of questions like that are asked. So you need to have your calculations pretty fast. And from here, we're moving ahead to a coordinate covalent bond. Now, this is a kind of covalency. Once again, it's in red, so it's important, which involves one of the combining atoms contributing both of the shared electrons. That is a bond formed by shared pair of electrons with both electrons coming from the same atom. So now you understand the difference between covalent bond and a coordinate covalent bond. Coordinate bond is where both electrons are coming from the same atom, and you can have combinations. Like for example, NaOH. Na plus है, metal है, OH एक radical है, OH minus. It's a group of atoms. But among O and H, it's a non-metal combination. So there is a covalent bond there between O and H. But OH is minus as a radical. So we have 2 kinds of bond. Between O and H, we have a covalent bond. And between metal and non-metal, Na plus and OH minus, we have the ionic bond. So we have ionic or electrovalent and covalent bond over here. Similarly, CaCO3, calcium is a metal, carbonate is a radical of non-metals. So ionic bond there, and among C and O3, there will be covalent bonds. So it's a combination of electrovalent and covalent. Now, an important question. Very important question, multiple choice question which is asked. Uh, which of the following compounds shows you all the three kinds of bonds? The options may be calcium chloride, carbon dioxide, ammonium chloride, and copper sulfate. Suppose this is the question. Your answer to this would be ammonium chloride, because ammonia आपने पढ़ा, ammonia में covalent bond था, 3 covalent bond. NH4 plus में we had one the lone pair effect and the coordinate bond coming there, and NH4 plus and Cl minus ionic bond. So all three. So whenever you have an ammonium salt there in the options, go for that. Now that is a trick I'm giving you. It's a trick. Ammonium salt, if it's there in the option, choose that option. Because ammonia to ammonium already gives you 2 bonds, and then one with the non-metal, the ionic bond. And from here, kids, this is an area where we have the table and a lot of give reasons are asked from here. Now, most of y'all do not write give reasons properly. I find that the keywords are missing. So we have like strong electrostatic force. When we're talking about the state, that is when something is an ionic compound, the physical state of that substance would be a solid. It will be a solid because the bond is strong. The words there, why is it a solid? Suppose I say sodium chloride is a solid. Why? So it is because there are ions which attract each other, and there are strong electrostatic force of attraction between the ions. So that is your keyword, strong electrostatic force. On the other hand, if I say ammonia is a gas, give reason why. Ammonia is a covalent compound. सबसे पहले covalent word लिखोगे. Covalent compound and a weak van der Waals force of attraction between them. So the key word there is van der Waals force, and here it is strong electrostatic force. If you want, you can take a screenshot of this so that you know which are the highlights and what you have to mention in the answer. You can take a screenshot if needed. And obviously, why do we have high melting point and boiling point for something like sodium chloride? It's because, again, of the strong electrostatic force of attraction. And obviously, if the attraction is strong, it will require a large amount of energy to break it. On the other side, here we have soft solids, gases, or liquids in covalent compounds, because van der Waals forces of attraction are weak and requires less amount of energy to break them. We move further to conduction of heat, obviously metal, non-metal combination. Magar, ionic compounds, we are not talking about wires, we are talking about chemicals. And chemicals will not conduct electricity in the solid state. Understand that you cannot put sodium chloride in a beaker, put an anode and a cathode and say कि चलो electricity pass करते हैं, नहीं होगी. उसको liquid state में करना है. या तो you make a solution of it, because we require free ions, we need flow of ions, charged particles. For the flow, we need a liquid state. So it's not going to pass, electricity is not going to pass through a solid chemical. It has to be liquid. The first rule is molten state or even in solution. And the free ions have to migrate towards the oppositely charged electrons. So the keyword there, molten or aqueous solution state. Mention that in your answer. Why is something a good conductor? Why is something a bad conductor? For example, magnesium chloride, we can say I require a molten magnesium chloride, true or false, is a good conductor. No. If it is a correct statement, I'll say molten magnesium chloride or a solution of magnesium chloride is a good conductor. Because that one word, important keyword missing there is molten or aqueous state. And this kind of thing is given in correct the statement. On the other hand, with non-polar covalent compounds, there is nothing of this kind. There are no free ions, there are no separations, and therefore they will not conduct electricity. So polar covalent compounds may fir bhi, we can have some amount of electricity passing through because of that polarity, plus minus polarity. And obviously, when we're talking about solubility, ionic compounds dissolve in water because water has high dielectric constant, keyword there, which means the capacity to weaken the force of attraction, resulting in free ions. Once again, screenshot it if you want to have it in your textbook, you can mark it out. And obviously, organic solvents don't have high dielectric constant, so they will not dissolve ionic compounds. Similarly, for covalent compounds on this side, they will organic solvents dissolve non-polar covalent compounds, but not water. Water does not dissolve it. Let's go to the last part of the chapter, which is we are talking about reactions. Free ions are easily formed in solution, okay, and they regroup when it's an ionic compound. So ions were already there in an electrovalent compound, plus minus charge was already there. Water separated it. So when water separated it, when there's a reaction, these charged ions will go and attach somewhere else. So regrouping is easy because they were originally charged. And with covalent compounds, you'll have to break the bonds first and then make new bonds. And so obviously the reactions are going to be slow. So here free ions, which are charged ions, which are charged particles, which are going to separate out in water and regroup. Faster reactions here and slower reactions in covalent compounds. A very important thing for ionic compounds is they undergo, or electrovalent compounds is they undergo dissociation. Most kids, electrovalent compound, ionic compound, ionization. This is what they think, wrong. Ionic compound mein ions already are there. So they will just separate. When we say ionic compounds, it means ions are already existing. They will just separate. So the word there is dissociation, because the process involves only separation of ions, which are already present. For covalent compounds, there were no ions. So if ions are going to be formed, we are going to use the word ionization over there. Undergoes ionization in solution state. So this is what we need to understand. This is, the dark areas are your important points, and you have to mention them in your reasons. So I hope the chapter is a little easier for you now, and want to just thank you for being with us. And Arihant Academy will come up with more lectures in other subjects too. So all of you, please stay tuned. Thank you so much.